So, I'm just going to say it. It's divisive, but I'm going to say it. When it comes to guitars, wood is an inferior material. There's so many things we do to this guitar neck only because wood is an inferior material. And it starts with things like using quarter sawn wood neck blanks. We use quarter sawn wood because it's stronger. We want to be able to counteract the tension that the strings are putting on the neck. Sometimes 60 years ago, someone put steel in the neck to once again attempt to try to counteract all the tension from those strings. And then of course, lately we've been adding these carbon fiber strengthening rods. We also laminate necks. We do all sorts of things to ensure that that neck doesn't move when it is actually in different climates, when it's in different humidity, when it's in different temperature. All those things we do because wood is an inferior material for building guitars. This is the neck for the travel guitar, and we're going to try a whole bunch of cool, new, interesting things, including not using a truss rod. This is the DragonPlate carbon fiber D-tube reinforcement beam. What we do is we route out the wood and we epoxy it in place. The D-tube itself weighs less than the wood that came out of it. Together, I just weighed this, the D-tube reinforcement beam plus the epoxy plus this neck, this weighs 175 grams. It is super light. I want to say, I haven't weighed this truss rod. You can weigh your truss rod at home. That this truss rod is probably heavier than this together. So today we're going to watch a little bit of the travel guitar construction. We're going to take a look at some of the neck machining, and we'll take a look at the installation of the D-tube reinforcement beam. Well, let's get to it. So I got all the back operations complete. So I did the contour when it was on the front side. And I add these 20 millimeter or so tabs here, here, and there. And I'm already accounting for any type of carves that are going to be in the back. So you can see this one, there was a carve here that kind of starts here and slopes down, and it ate through some of that tab, and that's cool. I account for that. So there's more tab beneath it to hold everything in place. And this slope is actually really subtle. It's more drastic towards the edge of the guitar, so this tip is very deep. So, I mean, from the stock, it's about, I don't know, 10 mil down. And then over here, it's also about, I don't know, maybe 8 mil down. But then the closer you get inside here, there's basically nothing there. Very subtle slope. The cavity is actually really interesting. So in this case, I'm accounting for a lot of things that are on the front of the guitar. So there's a lot of geometry in here, as you can see. You'll notice this little shape here looks like a T shape. This is essentially accounting for the bridge plate. So the bridge, which runs this way on the front, is going to have screws that it needs to actually screw into the wood. And that's what this is for. So this is this little lip here. It's just a corner of a square, which means if you follow these lines this way, that's where the cutout is for the headless tuners to get your finger in. Because it's on the front and it's going into the body, I need to account for that here in the cavity. So it's a tiny little lip there. This was that section here for the pot that I was mentioning. So essentially this is a little step so the pot can sit on it. So most of the actual volume knob is sunken into the volume cavity and it's not sticking out, which is what I want. I want something low profile. And then this guy here is, as I mentioned, for the bridge plate. So these interesting little artifacts are the type of things I can design in CAD and then run one toolpath, a 3D adaptive toolpath, and it takes care of all that. It even took care of the lip here for the cover, which it wasn't supposed to. That was my error. But this is super, super quick and easy. I want to say that the entire operation was almost like 4 minutes or something for all of this, which is great. Instead of the M3 bolts, I'm using M2 inserts. So it'll be very small M2 bolts with very small M2 inserts. And that just lets me have a 3 millimeter lip for the cover. It's also 3.1 millimeters high to account for any deviation in aluminum or acrylic that I'm going to use. And I like the way this looks, as opposed to making a wider lip to account for the M3 inserts, which are 5 mil in diameter. So this one up here, I had the space. I could put anything I wanted here. This is a 5 mil diameter cavity for the M3 insert. This is all designed incorrectly. So that tool path should have eaten more meat here and given me more space for that insert, and it didn't. So it means I'm just gonna have to modify the cover to fit into this new curve here. Not a big deal. So in the last video I mentioned that I made this tiny little channel here. In most cases your cavity can end way down here, right? This cavity only has really two purposes: to house the pot for the volume knob and the barrel jack. But for me, it has a third purpose, and that is to ensure that when I'm drilling the wire channel from the front pickup, I'm guaranteed to hit the cavity. So if you've ever drilled a wire channel from a front pickup to the cavity, that's quite a bit of eyeballing. There's quite a bit of guesswork. You have to kind of eyeball and determine the kind of pitch and the angle and all that to ensure that you're going to hit that cavity. And if your cavity ends way down here, you're looking at what, 15 centimeters or so? That's quite a distance to go, and it's quite a bit of guesswork. So to take the guesswork out, I make this little channel here. So now, my front pickup, I really only have to, I don't know, maybe drill like 50 millimeters or so. And that's a lot less guesswork, and I don't have to rely too much on eyeballing it. I can take the corner of that cavity and then just drill down, and I'm guaranteed to hit somewhere in there. And that's the point of this. All right, that's it. Let's take this off the table. All right, so I have all the top operations done for the neck. So I started with this route for the D-rod. So it came out really nice. I bought that bit. That's the exact dimension of the D-rod. So all I needed to do was determine how deep I needed to go and the length, and I figured that all out. And so this is the first cut, and it's super smooth. The D-rod fits in there nice and snugly, and there's a little bit of room for that epoxy. And the next operation I did was for this nice little negative space. So what I'm going to have is basically a hole, but it's in the shape of my headstock, and I think it's going to look really nice. And then we went with the locator pins as the next operation. And the last thing I did was the recess for the locking fixture. So this is going to be headless design, so it has like those locking nuts. It's got a base plate, and this is just a tiny little recess, which is exactly 2 millimeters deep. That 2 mil is going to be enough of a break angle for the strings that are sitting on the nut to angle back and go into the locking portions of that plate. All I need to do is take this off the table, put the exact same hole in the wasteboard, flip it, and then we'll do the back operations. So, a lot of next steps. We still have to add fret slots onto the fretboard, glue the fretboard onto the neck, sand the body, sand the neck, do a fret job. A lot of work on this travel guitar. I also have 4 concurrent projects going on at the same time with a couple of different series that I'm working on. I have the Silvertone restoration of the case here, the Silvertone amp there. I have the actual guitar indoors. I have a few other electronic projects that I'm working on that I'll be filming. A lot of good stuff for content coming in the future. But for the travel guitar, this is a good stopping point. Thanks for watching. Take it easy.